Welcome to Sleepy Secrets. I'm so glad you're here. Let your body settle into comfort, let your breathing slow, and allow your mind to drift. You don't need to remember anything. Just listen, breathe, and let the words wash over you like gentle waves. If you fall asleep, that's perfect. Get comfortable, close your eyes, and let's begin our journey into the deep. Tonight, we're diving into the vast, mysterious ocean, a world that covers most of our planet yet remains almost entirely unknown. From the sunlit surface to the crushing darkness of the deepest trenches, from creatures that create their own light to underwater mountains taller than any on land, the ocean is hiding wonders beyond imagination. Let go, breathe deeply, and allow yourself to sink into the peaceful depths. The ocean covers more than 70% of Earth's surface, a vast blue blanket that wraps our planet in liquid embrace, yet we have mapped less than 5% of this hidden world. We know more about the surface of Mars than we do about the ocean floor beneath the waves we see every day. This immense mystery stretches from pole to pole, a realm of endless discovery waiting in the deep. The deepest part of the ocean is the Mariana Trench, plunging nearly 7 miles down into darkness so complete that sunlight will never reach it. If you were to drop Mount Everest into this abyss, its peak would still be over a mile underwater. The ocean contains 97% of all water on Earth, leaving just 3% for all the lakes, rivers, ice caps, and groundwater combined. This immense reservoir has been here for billions of years, cycling through evaporation and rain, through ice and steam, through every living thing that has ever existed. Ocean water is not just salt and water, it contains traces of every element on the periodic table, including gold dissolved in the salt. Scientists estimate that 20 million tons of gold are scattered throughout the ocean's vast expanse. The ocean produces over 50% of the oxygen we breathe through tiny marine plants called phytoplankton, making them more important to our survival than all the rainforests combined. The ocean moves in ways we are only beginning to understand, with currents that transport more water than all the rivers on Earth combined. The Gulf Stream alone carries 100 times more water than the mighty Amazon, flowing like a blue highway through the Atlantic, carrying warmth from the tropics to the poles. These underwater rivers never stop moving, never rest, in an eternal dance that has continued for millions of years. When the moon rises in the night sky, it reaches across the vastness of space to pull on our oceans, creating the rhythmic rise and fall of the tides. This is not a simple pulling, it is a complex dance of gravity, with the side of Earth facing the moon experiencing one high tide while the opposite side experiences another. The average depth of the ocean is over 12,000 feet, and most of this vast underwater world exists in complete darkness, a realm we call the Midnight Zone. Ocean currents act as Earth's conveyor belt, moving heat from the equator to the poles, distributing nutrients across vast distances, and regulating the climate of the entire planet. This global circulation system takes over 1,000 years to complete one full circuit, moving slowly through the deep ocean like a great, sleeping giant. The ocean absorbs about 30% of the carbon dioxide we release into the atmosphere, acting as a massive sponge that slows the pace of climate change. But this service comes at a cost. As the ocean absorbs this carbon, it becomes more acidic, changing the chemistry of the water. Ocean pressure increases dramatically with depth, and at the bottom of the Mariana Trench, the pressure is over 8 tons per square inch, equivalent to 50 jumbo jets stacked on top of you. The Great Barrier Reef stretches for over 1,400 miles along the coast of Australia, a living structure so massive it can be seen from space, built by billions of tiny coral polyps working together over millions of years. Each polyp is no bigger than a pinhead, yet together they have created the largest living thing on Earth. Coral reefs cover less than 1% of the ocean floor, yet they support 25% of all marine species, making them the rainforests of the sea. Coral is not a plant or a rock, it's an animal made up of thousands of tiny polyps, each working together as one organism. These remarkable creatures have a symbiotic relationship with algae that live inside them, providing food through photosynthesis while the coral provides shelter. When water gets too warm, coral expel their algae and turn white in a process called bleaching, and without their algae, they slowly starve to death. Coral reefs protect coastlines from storms and erosion, absorbing up to 97% of wave energy, acting as natural barriers that have protected shorelines for millions of years. Some coral species can reproduce both sexually and asexually, cloning themselves or releasing eggs and sperm into the water for fertilization. Coral reefs are worth billions of dollars to the global economy through tourism, fishing, and coastal protection, supporting over 500 million people worldwide. The colors of coral come from the algae living inside them, and without algae, coral are actually transparent, revealing their white calcium carbonate skeletons. Coral can live for hundreds or even thousands of years, with some massive coral colonies being over 4,000 years old, older than the pyramids of Egypt. The twilight zone lies between 600 and 3,000 feet deep, a realm of perpetual dimness where sunlight fades to nothing and eternal dusk reigns supreme. Creatures in the twilight zone have evolved remarkable adaptations, with many having enormous eyes to capture every possible photon of light in this dim world. The twilight zone contains more fish than all the world's fisheries combined, making it the largest ecosystem on Earth, yet we rarely see it or understand it. Many twilight zone creatures migrate vertically every single night, rising to the surface to feed under cover of darkness in what is the largest migration on Earth. This great rising and falling has been happening for millions of years, a heartbeat of the ocean that never stops, never rests. The twilight zone is home to the hatchetfish, with its bizarre upward-pointing mouth and tubular eyes designed to spot prey silhouetted against faint light above. Viperfish live in the twilight zone and have fangs so long they can't close their mouths, their teeth curving back to prevent prey from escaping. The twilight zone is not empty, it's teeming with life, but the creatures are spread out in the vast darkness, making encounters rare and precious. Many twilight zone animals are red or black because red light doesn't penetrate this deep, so red animals appear black and invisible to predators. The twilight zone plays a crucial role in carbon cycling, with dead organisms and waste sinking through it, carrying carbon from the surface to the deep ocean. Lanternfish are the most abundant fish in the twilight zone, producing light from organs called photophores, creating patterns unique to their species. The midnight zone begins at 3,000 feet and extends to the ocean floor, a place where there is absolutely no sunlight, where darkness is so complete it becomes a physical presence. Despite the darkness, the midnight zone is not lifeless. Creatures here have evolved to survive in one of Earth's most extreme environments. Pressure in the midnight zone is over 400 times greater than at the surface, and only specially adapted creatures can survive this crushing weight. The midnight zone is cold, dark, and vast, making up over 90% of the ocean's living space, a realm of endless night. Creatures here rely on bioluminescence, creating their own light, and over 90% of midnight zone animals can produce light through chemical reactions. The anglerfish is the most famous midnight zone resident, with females having a glowing lure that dangles in front of their mouths to attract prey in the darkness. Male anglerfish are tiny compared to females, and when they find a female, they bite onto her and permanently fuse with her body, becoming nothing more than a pair of testicles. The midnight zone is home to giant squid, which can grow up to 43 feet long, making them among the largest invertebrates on Earth. Giant squid have the largest eyes in the animal kingdom, each about the size of a dinner plate, used to spot sperm whales, their only predator. Food is extremely scarce in the midnight zone, and creatures often go weeks or months between meals, surviving on whatever drifts down from above. The midnight zone contains hydrothermal vents, underwater geysers that spew superheated, mineral-rich water where life thrives in impossible conditions. Creatures around hydrothermal vents don't rely on sunlight at all. Instead, they use chemosynthesis, converting chemicals from the vents into energy in a process as miraculous as photosynthesis. Tube worms live near hydrothermal vents and can grow up to 8 feet long despite having no mouth or digestive system, relying entirely on symbiotic bacteria. These remarkable creatures have evolved to live in water that is hot enough to melt lead, in conditions that would instantly kill any surface creature. The water spewing from hydrothermal vents can reach temperatures of over 700 degrees Fahrenheit, yet life not only survives but thrives in these extreme conditions. Hydrothermal vents were only discovered in 1977, revealing an entire ecosystem that exists completely independent of sunlight, changing our understanding of where life can exist. The minerals spewing from these vents create towering chimneys that can grow hundreds of feet tall, building underwater cathedrals in the darkness. Creatures at hydrothermal vents include giant clams, blind shrimp, and strange worms, all adapted to life in this extreme environment. These vents are found along mid-ocean ridges where tectonic plates are spreading apart, creating new ocean floor and releasing heat from Earth's interior. The ecosystems around hydrothermal vents are completely isolated from the surface world, evolving in their own unique ways for millions of years. Heat from hydrothermal vents can warm the surrounding water for miles, creating oases of warmth in the cold deep ocean. The chemicals from these vents may have been where life on Earth first began, providing the energy and ingredients necessary for the first living organisms. Deep in the ocean's darkest depths, creatures create their own light through the magic of bioluminescence, producing cold, chemical light that glows in blues and greens. These living lanterns produce light that can travel through the deep water, the only colors that can penetrate the crushing darkness of the midnight zone. Some creatures use this light to attract prey, dangling glowing lures in the darkness like fishermen in the night, waiting for curious victims to approach. Others use bioluminescence to communicate, to camouflage, or to startle predators, painting the abyss with living stars in a spectacular light show. Bioluminescent plankton light up the waves at night, creating glowing blue trails that follow boats and surfers, a magical display that has inspired wonder in humans for thousands of years. This light is created through a chemical reaction that produces almost no heat, a cold fire that can be triggered by movement, by touch, by the simple disturbance of water. When you see these glowing waves, you are witnessing the same phenomenon that guided ancient sailors and continues to inspire awe in anyone lucky enough to experience it. The light produced by bioluminescent creatures is usually blue because blue light travels farthest through water, making it the most efficient color for communication in the deep. Some deep-sea creatures have light organs called photophores that they can turn on and off at will, creating complex patterns and signals. Bioluminescence is so common in the deep ocean that some scientists believe most creatures living below 1,000 feet can produce light in some form. The chemical reaction that creates bioluminescence involves a molecule called luciferin and an enzyme called luciferase, the same chemicals that make fireflies glow on land. Whales are the largest animals to ever exist on Earth, larger than any dinosaur that ever walked the land, yet they feed on some of the smallest creatures in the ocean. The blue whale can grow up to 100 feet long and weigh as much as 200 tons, a living island that moves through the ocean with grace and power. Despite their enormous size, blue whales feed almost exclusively on tiny shrimp-like creatures called krill, consuming up to 4 tons of them every single day. Whales sing songs that travel thousands of miles through the ocean, complex melodies that can last for hours, carrying across entire ocean basins through channels of water that transmit sound with remarkable efficiency. These songs are so powerful and so far-reaching that a whale in the Atlantic might theoretically communicate with one in the Pacific, their voices traveling through the deep like messages in bottles. We still don't fully understand what these songs mean, but they speak of an intelligence and culture we are only beginning to comprehend. Sperm whales dive deeper than any other whale, plunging over 7,000 feet down into the midnight zone to hunt giant squid in the eternal darkness. These dives can last over an hour, with the whales holding their breath and surviving pressures that would crush a human instantly. Humpback whales are known for their acrobatic breaches, launching their massive bodies out of the water in displays of power and grace that never fail to amaze. Whales have been on Earth for over 50 million years, evolving from land-dwelling ancestors that gradually returned to the sea, adapting to life in the water over millions of years. The ocean is home to many giant creatures beyond whales, including giant squid, colossal squid, and massive jellyfish that drift through the currents like living ghosts. The ocean is not just water, it is a complex mixture containing salts, minerals, gases, and organic matter that has been accumulating and circulating for billions of years. Every drop of seawater contains atoms that have been part of ancient oceans, part of dinosaurs, part of stars that exploded before our sun was born. When you swim in the ocean, you are touching water that has been everywhere, done everything, a liquid that connects you to every living thing that has ever existed. The salt in the ocean comes from rocks on land that have been weathered by rain and carried by rivers to the sea over millions of years. This salt has been accumulating for billions of years, making the ocean salter and salter with each passing millennium. The ocean contains every element on the periodic table, though most are present in such tiny amounts that they are difficult to detect. Ocean water is constantly being recycled through the water cycle, evaporating into the atmosphere, falling as rain, and returning to the sea in an endless loop. The temperature of the ocean varies from freezing at the poles to over 80 degrees Fahrenheit in tropical surface waters, creating different environments for different creatures. Ocean water is denser than fresh water because of the salt, which is why it's easier to float in the ocean than in a lake or river. The pH of the ocean is slightly alkaline, but it's becoming more acidic as it absorbs carbon dioxide from the atmosphere, changing the chemistry of the water. The ocean holds dissolved gases including oxygen and carbon dioxide, which are essential for marine life and play crucial roles in Earth's climate system. Deep-sea exploration has revealed creatures so bizarre they seem alien, with transparent bodies, bioluminescent organs, and adaptations that allow them to survive in conditions that would be instantly fatal to surface life. Each expedition into the deep reveals new species, new mysteries, new evidence of life's incredible ability to adapt and thrive in the most extreme environments imaginable. The gulper eel has a mouth that can open wide enough to swallow prey larger than itself, a remarkable adaptation for a world where food is scarce and opportunities must be seized. The vampire squid is neither a vampire nor a squid, but a unique creature that lives in the oxygen minimum zone, surviving in conditions that would kill most other animals. Deep-sea creatures have evolved to survive in a world without seasons, without day or night, without the rhythms that govern life on the surface. For them, time moves differently, marked not by the sun but by the slow drift of currents, the rare fall of food from above, and the occasional encounter with another living being. Their existence is one of patience and stillness, adapted to a world where energy is precious and every movement must count. The Dumbo octopus lives in the deep ocean and uses ear-like fins to glide through the water, moving with a grace that seems almost magical in the darkness. Deep-sea jellyfish can grow to enormous sizes, with some species having tentacles that stretch over 100 feet long, drifting through the deep like living ghosts. The pressure at the bottom of the ocean is so immense that it equals the weight of 50 jumbo jets stacked on top of you, yet creatures there live their entire lives without even noticing it. They have evolved to exist in this crushing environment, their bodies adapted to pressures that would instantly destroy anything from the surface. Ocean currents act as Earth's conveyor belt, moving heat from the equator to the poles, distributing nutrients across vast distances, and regulating the climate of the entire planet. This global circulation system, called the thermohaline circulation, takes over 1,000 years to complete one full circuit, moving slowly through the deep ocean like a great, sleeping giant that shapes the world in ways we barely understand. The Gulf Stream is one of the most powerful currents on Earth, carrying warm water from the Gulf of Mexico across the Atlantic to Europe, keeping the climate of northern Europe much warmer than it would otherwise be. Without the Gulf Stream, countries like England and Norway would have climates similar to Canada at the same latitude. Currents are driven by wind, temperature differences, salinity differences, and the rotation of the Earth, creating a complex system of moving water that never stops. Deep ocean currents are created when cold, dense water sinks at the poles and flows along the ocean floor toward the equator, while warm surface water flows toward the poles to replace it. This constant circulation brings oxygen to the deep ocean and nutrients to the surface, supporting life throughout the water column. The Antarctic Circumpolar Current is the largest current on Earth, flowing around Antarctica and connecting the Atlantic, Pacific, and Indian Oceans in a continuous loop. Ocean currents can be disrupted by climate change, which could have dramatic effects on weather patterns, marine life, and the global climate system. Marine animals use ocean currents to migrate, to find food, and to disperse their young, relying on these underwater highways to navigate the vast ocean. Marine snow, that constant shower of organic matter drifting down from the surface, provides the primary food source for creatures in the deep ocean. This snow is made up of dead plankton, fecal matter, and other organic debris, falling slowly through the water column like dust motes in a sunbeam, carrying energy from the sunlit surface to the dark depths below. This gentle rain of nutrients has been falling for millions of years, sustaining life in a world without sunlight, providing the energy that allows deep-sea creatures to survive. Marine snow falls at a rate of about 100 to 300 feet per day, taking weeks or months to reach the ocean floor from the surface. As it falls, marine snow is consumed by creatures in the water column, with each particle potentially being eaten and excreted multiple times before reaching the bottom. Large particles of marine snow can form aggregates that fall much faster than individual particles, creating pulses of food that deep-sea creatures wait for eagerly. Marine snow is not just food, it also carries carbon from the surface to the deep ocean, playing a crucial role in the global carbon cycle and helping to regulate Earth's climate. The amount of marine snow that reaches the ocean floor varies depending on the productivity of the surface waters above, with more snow falling in areas where there is abundant plankton. Deep-sea creatures have evolved to detect and capture marine snow, with some having specialized feeding structures designed to catch these falling particles. Marine snow can also carry pollutants from the surface to the deep ocean, spreading contamination throughout the water column and affecting deep-sea ecosystems. The sound of the ocean is a symphony of life, the songs of whales that travel for thousands of miles, the crackling of shrimp that can be louder than a jet engine, the deep rumbling of underwater earthquakes, and the constant rush of waves against the shore. This underwater soundscape has existed for millions of years, a background noise to the evolution of marine life, a communication network that connects creatures across vast distances of water. Sound travels nearly 5 times faster in water than in air, allowing it to carry much farther and making the ocean a world where sound is more important than sight. Many marine animals rely on sound to navigate, to find food, to communicate, and to avoid predators in the dark waters where vision is limited. The snapping shrimp produces sound by snapping its claw so fast that it creates a bubble that collapses with a loud pop, and the combined sound of millions of these shrimp creates a constant crackling in the ocean. Whale songs can be heard across entire ocean basins, with low-frequency sounds traveling thousands of miles through deep water channels that act like underwater highways for sound. The ocean has its own background noise created by wind, waves, rain, and ice, a constant hum that has been present since the ocean first formed. Human activities are adding noise to the ocean through shipping, sonar, and industrial activities, creating noise pollution that can interfere with marine animals' ability to communicate and navigate. Some deep-sea creatures produce sound to attract prey, to communicate with others of their species, or to defend themselves from predators in the darkness. The study of ocean sounds is called bioacoustics, and it's helping scientists understand marine life in new ways by listening to the underwater world. Tidal pools create miniature ocean worlds along the shore, isolated ecosystems that must survive the extremes of high tide and low tide, of submersion and exposure, of temperature changes and salinity fluctuations. Creatures in these pools have evolved remarkable adaptations to survive these challenging conditions, creating resilient communities that thrive at the edge of the ocean. When the tide goes out, tidal pools trap seawater and the creatures that live in it, creating isolated worlds that must survive until the tide returns. The temperature in tidal pools can change dramatically, heating up in the sun during low tide and cooling down when the tide returns, requiring creatures to tolerate wide temperature ranges. Salinity in tidal pools can also change as water evaporates in the sun, making the water salter, or as rain dilutes it, making it fresher, creating challenging conditions for the inhabitants. Tidal pools are home to sea stars, sea anemones, crabs, snails, and many other creatures that have adapted to life in these dynamic environments. Sea anemones can close up and retain water when the tide is out, protecting themselves from drying out and from predators that might be looking for an easy meal. Crabs in tidal pools have evolved to breathe air as well as water, allowing them to survive when the tide goes out and their pool becomes isolated. Tidal pools are important nurseries for many marine species, providing protected areas where young creatures can grow before venturing out into the open ocean. The creatures in tidal pools must also deal with waves crashing over them when the tide returns, requiring strong attachments or the ability to hide in crevices. The ocean floor is more mountainous than any landscape on land, with underwater ranges that stretch for thousands of miles, volcanoes that tower higher than Mount Everest, and trenches deeper than anything we experience on the surface. The Mid-Atlantic Ridge, that great underwater mountain range, is the longest mountain chain on Earth, yet most of it lies hidden beneath miles of water, unseen and unknown. These underwater mountains are formed by volcanic activity and tectonic processes, creating a landscape as dramatic and varied as anything on the continents above. Seamounts are underwater mountains that rise from the ocean floor but don't reach the surface, creating isolated habitats that support unique communities of marine life. These underwater islands can be thousands of feet tall, yet their peaks may still be hundreds of feet below the surface, hidden from view. Seamounts disrupt ocean currents, causing upwelling that brings nutrients from the deep to the surface, creating areas of high productivity that attract large numbers of fish and other marine animals. Many seamounts are ancient volcanoes that are no longer active, their peaks worn down by currents and time, yet they still provide important habitat for deep-sea creatures. The underwater mountains of the ocean are connected by vast plains and valleys, creating a complex topography that influences ocean circulation and marine life distribution. Ocean mountains can affect climate by influencing ocean currents and upwelling patterns, playing a role in the global climate system that we are only beginning to understand. The deepest parts of the ocean are found in trenches that are formed where tectonic plates collide, creating scars in the ocean floor that plunge deeper than the height of the tallest mountains. Beneath the waves lie thousands of shipwrecks, each one a time capsule frozen in the moment it sank, preserving artifacts and stories from every era of human history. From ancient Greek trading vessels to World War II battleships, these underwater museums hold treasures and tragedies, slowly being claimed by the ocean as coral grows over metal and fish make homes in broken hulls. The ocean keeps our history in its depths, a library of human experience written in rust and coral, waiting to be rediscovered by those brave enough to explore the deep. Ancient underwater cities lie buried beneath the waves, lost to rising sea levels and geological changes over thousands of years, preserving the stories of civilizations that thrived when the land was dry. These submerged ruins hold the secrets of our ancestors, now preserved in the cold, dark water where time moves differently and decay is slowed. The ocean has been rising and falling throughout Earth's history, with sea levels changing by hundreds of feet over geological time, exposing and flooding continental shelves. During the last ice age, sea levels were over 400 feet lower than today, exposing land bridges that allowed humans and animals to migrate between continents. As the ice age ended and glaciers melted, the ocean rose again, flooding coastal areas and creating the coastlines we know today. The ocean floor contains evidence of past climate changes, with layers of sediment recording temperature changes, volcanic eruptions, and other events from Earth's history. Scientists study these ocean records to understand past climate changes and predict future changes, using the ocean as a window into Earth's past. The color of the ocean changes from deep blue to turquoise to green depending on what lives in the water, what minerals are dissolved in it, and how the light penetrates the depths. This ever-changing palette has inspired artists for thousands of years, a source of beauty and wonder that never grows old, never stops revealing new shades and tones. The ocean is a painter's dream, a canvas that changes with every wave, every current, every shift in the light, creating an endless variety of colors and patterns. The deep blue color of the open ocean is created by the way water absorbs and scatters light, with blue light being scattered the most and traveling the farthest through water. Coastal waters often appear green or turquoise because of the presence of phytoplankton, sediment, and other particles that change the way light is absorbed and scattered. The color of the ocean can indicate the health of the ecosystem, with changes in color signaling changes in plankton populations, pollution levels, or water temperature. Satellite images of the ocean show variations in color that reveal ocean currents, plankton blooms, and other features that are invisible to the naked eye. The ocean appears black at great depths because there is no light to scatter, creating a darkness so complete that it becomes a physical presence. Some creatures in the deep ocean are red because red light doesn't penetrate to those depths, making them effectively invisible to predators and prey. The color of the ocean at sunset can be spectacular, with the water reflecting the colors of the sky and creating a mirror of fire and gold. The pressure at the bottom of the ocean is so immense that it equals the weight of 50 jumbo jets stacked on top of you, yet creatures there live their entire lives without even noticing it. They have evolved to exist in this crushing environment, their bodies adapted to pressures that would instantly destroy anything from the surface. To them, this extreme pressure is simply home, as natural and unremarkable as the air we breathe is to us. Pressure in the ocean increases by 1 atmosphere for every 33 feet of depth, creating a gradient that ranges from 1 atmosphere at the surface to over 1,000 atmospheres in the deepest trenches. Deep-sea creatures have evolved various adaptations to survive this pressure, including flexible cell membranes, special proteins that function under pressure, and bodies that are mostly water, which is incompressible. Some deep-sea creatures cannot survive being brought to the surface because the rapid change in pressure causes their bodies to expand and rupture. The pressure in the deep ocean keeps water liquid at temperatures where it would normally freeze, allowing liquid water to exist in conditions that would otherwise be impossible. Submarines and deep-sea vehicles must be specially designed to withstand the crushing pressure of the deep ocean, with thick hulls and special materials that can resist the force of the water. The pressure of the ocean has been used to preserve ancient shipwrecks, keeping them in remarkable condition for hundreds or even thousands of years. Scientists study how deep-sea creatures adapt to pressure to understand the limits of life and to develop new materials and technologies. The temperature of the ocean varies from freezing at the poles to over 80 degrees Fahrenheit in tropical surface waters, creating different environments for different creatures and influencing global climate patterns. The ocean has distinct temperature layers, with warm water at the surface, a rapid temperature change called the thermocline in the middle, and cold water at depth. This layering affects the distribution of marine life, with different species adapted to different temperature ranges and unable to cross the thermocline. The ocean absorbs and stores heat from the sun, acting as a massive thermal battery that helps regulate Earth's climate and moderates temperature extremes. Without the ocean's ability to absorb and redistribute heat, Earth's climate would be far more extreme, with much hotter days and much colder nights. Ocean temperature affects weather patterns, with warm ocean water fueling hurricanes and typhoons, and temperature differences between ocean regions driving atmospheric circulation. The ocean is warming due to climate change, with most of the extra heat trapped by greenhouse gases being absorbed by the ocean, causing sea temperatures to rise. This warming affects marine life, with some species moving to cooler waters, coral reefs bleaching, and ecosystems being disrupted by temperature changes. Deep ocean water is consistently cold, with temperatures near freezing in most of the deep ocean, creating a stable environment that has remained unchanged for millions of years. Ocean temperature influences the solubility of gases, with warmer water holding less oxygen, which can create dead zones where marine life cannot survive. The ocean is home to an incredible diversity of life, from microscopic plankton to the largest animals on Earth, with millions of species living in every part of the ocean from the surface to the deepest trenches. Scientists estimate that there may be millions of species in the ocean that we have never discovered, with the vast majority of marine life still unknown to science. The ocean contains representatives from every major group of life on Earth, with many groups existing only in the ocean and nowhere else on the planet. Marine life has evolved to fill every possible niche in the ocean, from filter feeders that strain plankton from the water to predators that hunt in the darkness of the deep. The diversity of life in the ocean is greatest in coral reefs and coastal areas, where sunlight, nutrients, and warm temperatures create ideal conditions for life to flourish. In the deep ocean, life is less diverse but no less remarkable, with creatures evolving bizarre adaptations to survive in the extreme conditions of the deep. The ocean is the original home of life on Earth, with all life evolving from marine ancestors that lived in the ocean billions of years ago. Marine ecosystems are interconnected, with energy and nutrients flowing through food webs that connect the smallest plankton to the largest whales. The ocean's biodiversity is threatened by human activities including overfishing, pollution, climate change, and habitat destruction, with many species facing extinction. Protecting ocean biodiversity is essential for maintaining healthy marine ecosystems and the services they provide to humanity. Most of the ocean remains unexplored, with less than 5% of the ocean floor mapped in detail and even less of the water column explored directly. We know more about the surface of Mars than we do about our own ocean, making the ocean the final frontier on our own planet. Ocean exploration requires specialized equipment including submersibles, remotely operated vehicles, and deep-sea cameras that can withstand the extreme conditions of the deep. Each expedition into the deep ocean reveals new species, new geological features, and new mysteries that challenge our understanding of the marine world. The deep ocean is difficult to explore because of the extreme pressure, darkness, and cold, requiring technology that can operate in conditions that would be fatal to humans. Ocean exploration has led to discoveries that have revolutionized our understanding of life, including hydrothermal vents and the creatures that live there without sunlight. New technologies are making ocean exploration more accessible, with advances in robotics, sensors, and imaging allowing us to see deeper and explore further than ever before. Ocean exploration is expensive and challenging, requiring international cooperation and significant resources to mount expeditions to the deepest parts of the ocean. Despite the challenges, ocean exploration continues to reveal the wonders of the deep, showing us that our own planet still holds mysteries waiting to be discovered. The future of ocean exploration will likely involve more autonomous vehicles, better sensors, and new ways of studying the ocean without disturbing its delicate ecosystems. The ocean plays a crucial role in Earth's climate system, absorbing heat, storing carbon, and redistributing warmth around the planet through ocean currents that connect all parts of the globe. The ocean has absorbed over 90% of the extra heat trapped by greenhouse gases, slowing the rate of climate change but causing the ocean to warm and expand. This warming is causing sea levels to rise, threatening coastal communities and changing the distribution of marine life as species move to cooler waters. The ocean absorbs about 30% of the carbon dioxide released by human activities, helping to slow climate change but making the ocean more acidic and threatening marine life. Ocean acidification affects creatures that build shells and skeletons from calcium carbonate, including coral, shellfish, and some plankton, with cascading effects throughout the marine food web. Changes in ocean temperature and chemistry are affecting marine ecosystems worldwide, with coral bleaching, species migrations, and disruptions to food webs being observed in oceans around the world. The ocean's ability to absorb carbon and heat is not unlimited, and as the ocean warms and becomes more acidic, its capacity to buffer climate change may decrease. Ocean circulation patterns are being affected by climate change, with potential disruptions to currents that could have dramatic effects on regional climates and marine ecosystems. The ocean and atmosphere are intimately connected, with changes in one affecting the other in complex feedback loops that influence global climate patterns. Understanding the ocean's role in climate is essential for predicting future climate change and developing strategies to mitigate its effects. Ocean currents influence weather patterns around the world, with warm currents bringing moisture and warmth to coastal areas and cold currents creating dry, cool conditions along western coasts of continents. The El Niño Southern Oscillation is a periodic warming of the eastern Pacific Ocean that affects weather patterns worldwide, causing droughts in some areas and floods in others. La Niña is the opposite pattern, with cooling of the eastern Pacific that also affects global weather, creating different patterns of drought and precipitation. Ocean currents affect the formation and intensity of hurricanes and typhoons, with warm ocean water providing the energy that fuels these powerful storms. The temperature of the ocean surface affects evaporation rates, which in turn affect cloud formation and precipitation patterns over both ocean and land. Ocean currents can moderate the climate of coastal areas, keeping temperatures more stable than inland areas at the same latitude. Changes in ocean currents due to climate change could alter weather patterns worldwide, with unpredictable effects on agriculture, water resources, and human settlements. The ocean and atmosphere exchange heat, moisture, and gases at their interface, creating a coupled system that determines Earth's climate and weather. Ocean eddies, which are rotating bodies of water similar to atmospheric storms, can affect local weather and ocean conditions, transporting heat and nutrients across the ocean. Understanding the relationship between ocean currents and weather is essential for improving weather forecasts and predicting the impacts of climate change. The ocean contains essential nutrients that support marine life, including nitrogen, phosphorus, iron, and silica, which are required by phytoplankton and other marine organisms for growth and reproduction. These nutrients are distributed unevenly throughout the ocean, with high concentrations in coastal areas and upwelling zones, and low concentrations in the open ocean gyres. Nutrients are recycled through the marine food web, with dead organisms and waste products sinking to the deep ocean and being broken down by bacteria, releasing nutrients back into the water. Upwelling brings nutrient-rich deep water to the surface, creating areas of high productivity that support abundant marine life and important fisheries. The availability of nutrients limits the growth of phytoplankton in many parts of the ocean, with iron being particularly important in limiting productivity in the open ocean. Human activities are adding excess nutrients to coastal waters through agricultural runoff and sewage, causing harmful algal blooms and dead zones where oxygen levels are too low to support marine life. Nutrients in the ocean are connected to the global carbon cycle, with phytoplankton using nutrients and carbon dioxide to grow, then sinking to the deep ocean when they die, sequestering carbon. The balance of nutrients in the ocean is delicate, with changes in nutrient availability affecting the composition of marine communities and the productivity of marine ecosystems. Deep ocean water is rich in nutrients that have accumulated from sinking organic matter over thousands of years, creating a reservoir of nutrients that can be brought to the surface by upwelling. Understanding nutrient cycles in the ocean is essential for managing fisheries, protecting marine ecosystems, and predicting the ocean's response to climate change. The ocean contains dissolved oxygen that is essential for marine life, with oxygen entering the water from the atmosphere and being produced by phytoplankton through photosynthesis. Oxygen levels in the ocean vary with depth, temperature, and biological activity, with the highest levels typically found in surface waters where photosynthesis occurs and the water is in contact with the atmosphere. As water warms, it holds less dissolved oxygen, which means that ocean warming due to climate change is reducing oxygen levels in many parts of the ocean. Oxygen minimum zones exist in the middle depths of the ocean where respiration by bacteria consuming sinking organic matter uses up oxygen faster than it can be replenished. These oxygen minimum zones are expanding due to climate change, creating areas where marine life cannot survive and forcing species to move to shallower or deeper waters. Marine animals have evolved various adaptations to survive in low oxygen environments, including larger gills, more efficient oxygen extraction, and the ability to reduce their metabolic rate. Dead zones are areas of the ocean where oxygen levels are so low that marine life cannot survive, often caused by excess nutrients from human activities that stimulate algal blooms and subsequent oxygen depletion. The ocean's oxygen content is connected to the global carbon cycle, with photosynthesis producing oxygen and respiration consuming it in a balance that has been maintained for millions of years. Changes in ocean circulation can affect oxygen distribution, with reduced circulation leading to lower oxygen levels in the deep ocean. Monitoring ocean oxygen levels is essential for understanding the health of marine ecosystems and predicting the impacts of climate change on marine life. The ocean floor is covered with sediments that have accumulated over millions of years, including clay, silt, sand, and the remains of marine organisms that have sunk to the bottom. These sediments record Earth's history, with layers of sediment preserving evidence of past climate changes, volcanic eruptions, and evolutionary events. Deep-sea sediments accumulate very slowly, at rates of millimeters per 1,000 years in some areas, creating a detailed record of Earth's history that can be read like the pages of a book. The composition of ocean sediments varies depending on location, with terrigenous sediments derived from land dominating near continents, and biogenic sediments made of the remains of marine organisms dominating in the open ocean. Calcareous ooze, made from the shells of plankton, covers large areas of the ocean floor above the carbonate compensation depth, while siliceous ooze, made from the skeletons of diatoms and radiolarians, dominates in areas of high productivity. Ocean sediments are disturbed by currents, earthquakes, and biological activity, creating a dynamic environment where sediments are constantly being moved and mixed. The study of ocean sediments, called marine geology, provides insights into plate tectonics, climate change, and the evolution of life on Earth. Sediments on the ocean floor contain valuable resources including oil, gas, and minerals, though extracting these resources can have significant environmental impacts. Ocean sediments play a role in the global carbon cycle, with organic carbon buried in sediments being removed from the active carbon cycle for millions of years. Understanding ocean sediments is essential for reconstructing Earth's history and predicting future changes in the ocean and climate. Ocean waves are created by wind blowing across the surface of the water, transferring energy from the atmosphere to the ocean and creating the rhythmic motion that characterizes the sea. Waves can travel thousands of miles across the ocean, carrying energy from storms in one part of the world to distant shores where they arrive as swells. The size of waves depends on wind speed, wind duration, and fetch, which is the distance over which the wind blows across the water. Tsunamis are massive waves created by underwater earthquakes, landslides, or volcanic eruptions, and can travel across entire ocean basins at speeds of up to 500 miles per hour. Unlike wind waves, tsunamis involve the movement of the entire water column from surface to bottom, and can cause devastating damage when they reach shore. Rogue waves are unusually large waves that appear unexpectedly in the open ocean, sometimes reaching heights of over 100 feet and posing a danger to ships. Waves shape coastlines through erosion and deposition, creating beaches, cliffs, and other coastal features that are constantly being modified by the action of the sea. The energy in ocean waves can be harnessed for renewable energy, though wave energy technology is still in development and faces challenges related to the harsh marine environment. Waves affect marine life in many ways, mixing nutrients, distributing plankton, and creating habitats in the intertidal zone where organisms must cope with the constant motion of the water. Understanding waves is essential for navigation, coastal management, and predicting the impacts of storms and sea level rise on coastal communities. The ocean faces numerous threats from human activities including overfishing, pollution, climate change, habitat destruction, and ocean acidification, all of which are affecting marine ecosystems worldwide. Overfishing has depleted many fish populations, with some species facing extinction and marine food webs being disrupted by the removal of key predators and prey. Plastic pollution is a growing problem in the ocean, with millions of tons of plastic entering the ocean each year, harming marine life through ingestion and entanglement. Chemical pollution from industrial activities, agriculture, and urban runoff contaminates coastal waters and accumulates in marine organisms, affecting their health and reproduction. Marine protected areas are established to conserve ocean biodiversity and protect critical habitats, though only a small percentage of the ocean is currently protected. Sustainable fishing practices are being developed to allow fishing to continue while maintaining healthy fish populations and marine ecosystems. Ocean conservation requires international cooperation, as the ocean is a global resource that crosses political boundaries and requires coordinated management. Public awareness of ocean issues is growing, with more people recognizing the importance of the ocean for climate regulation, food security, and biodiversity. Technological innovations are helping with ocean conservation, including better monitoring systems, sustainable aquaculture, and methods to clean up pollution. The future of the ocean depends on the choices we make today, with actions to reduce greenhouse gas emissions, protect marine habitats, and manage ocean resources sustainably being essential for the health of the ocean and the planet. The ocean provides essential resources for human health, including food, medicine, and recreation, with billions of people depending on the ocean for their livelihoods and nutrition. Seafood is an important source of protein and essential nutrients for billions of people worldwide, though overfishing and pollution are threatening the sustainability of fisheries. The ocean is a source of medicines, with compounds from marine organisms being used to treat cancer, pain, and other conditions, and many more potential medicines waiting to be discovered. Coastal environments provide opportunities for recreation and exercise, with activities like swimming, surfing, and beach walking contributing to physical and mental health. The ocean regulates climate and produces oxygen, providing essential ecosystem services that support human health and well-being on a global scale. Ocean pollution can affect human health through contaminated seafood, polluted beaches, and harmful algal blooms that produce toxins. Climate change impacts on the ocean, including sea level rise and ocean acidification, threaten coastal communities and the resources they depend on for their health and livelihoods. Mental health benefits of the ocean are increasingly recognized, with exposure to coastal environments reducing stress, anxiety, and depression. Ocean literacy, or understanding of the ocean and our relationship to it, is essential for making informed decisions about ocean conservation and sustainable use. Protecting ocean health is essential for protecting human health, with the two being intimately connected through the resources and services the ocean provides. In the heart of the Atlantic Ocean lies the Sargasso Sea, the only sea in the world without any land boundaries. It is defined not by shores, but by swirling ocean currents that trap floating mats of golden seaweed, creating a drifting, sunlit island in the middle of the deep blue. This unique ecosystem has been floating in the open ocean for millions of years, a quiet sanctuary for baby sea turtles and specialized fish that have evolved to live their entire lives hidden within the tangled, golden weeds. Deep on the ocean floor, there are underwater lakes known as brine pools, where water is so incredibly salty and dense that it refuses to mix with the surrounding seawater. These pools form distinct, shimmering shorelines on the sea floor, complete with gentle waves lapping against a liquid beach. The water in these pools is so toxic and dense that any creature that wanders in is instantly preserved, creating a haunting, beautiful graveyard of ancient marine life resting at the bottom of the deep. When a great whale finally passes away, its massive body sinks slowly through the water column in a gentle, months-long descent to the ocean floor. This event, known as a whale fall, creates a sudden, rich oasis of life in the barren deep sea, providing food and shelter for hundreds of species for decades. Specialized worms, crabs, and bacteria slowly break down the bones, turning a single moment of loss into a thriving, temporary city of life in the eternal darkness. Beneath the surface, there exists a phenomenon called the deep scattering layer, a dense band of marine life that moves up and down the water column every day. To early sonar operators, this layer appeared to be a false ocean floor, a phantom bottom that rose and fell with the sun. It is actually composed of billions of tiny creatures, fish, and plankton, moving together in a silent, synchronized dance that has been happening since the dawn of the oceans. In the freezing, dark waters of the deep ocean, glass sponges build ancient reefs that can live for thousands of years. Their skeletons are made of silica, forming intricate, lace-like structures that glow faintly in the dark. These fragile, beautiful architectures provide shelter for countless tiny creatures, standing like silent, crystalline cathedrals in the quiet, cold currents of the abyss. Near the hydrothermal vents, yeti crabs thrive in the extreme heat, their pale, hairy arms covered in specialized filaments. They use these furry arms to farm bacteria, gently waving them in the warm, mineral-rich water to cultivate their own food. It is a quiet, peaceful existence, a gentle tending of microscopic gardens in the most unlikely and hostile environment on Earth. In the twilight zone, the black dragonfish produces a rare, red bioluminescence, a color that most deep-sea creatures cannot see. This allows the dragonfish to shine a secret, invisible spotlight on its prey, hunting in the dark with a hidden light that only it can perceive. It is a master of the shadows, moving silently through the deep, unseen and unheard, a ghost in the midnight waters. At the very bottom of the Mariana Trench, the Mariana snailfish glides gracefully through the crushing darkness. It is the deepest living fish ever discovered, its body translucent and gelatinous, perfectly adapted to the immense pressure. It moves with a slow, effortless drift, a quiet survivor at the very edge of life's limits, thriving in a world that should be completely uninhabitable. Sea butterflies, tiny swimming snails with delicate, wing-like appendages, flutter through the cold polar waters. They drift like snowflakes in the current, their fragile, transparent shells catching the faint light. These gentle creatures are a vital part of the ocean's food web, drifting peacefully through the icy depths, a beautiful, fragile dance of life in the freezing sea. Deep beneath the waves, internal waves ripple through the ocean's layers, massive, invisible tsunamis that travel far below the surface. They can be hundreds of feet tall, moving slowly through the dark, mixing nutrients and shaping the deep ocean environment. Though unseen from above, these silent, giant waves are a constant, powerful force, quietly stirring the deep waters in a slow, rhythmic pulse. Where fresh river water meets the salty ocean, haloclines form, distinct layers of water with different densities that refuse to mix. These invisible boundaries create a shimmering, blurred effect in the water, bending light and creating a dreamlike, surreal landscape. It is a quiet meeting place of two worlds, a gentle, shifting border where fresh and salt water dance together without ever truly blending. On the abyssal plains, giant isopods, resembling massive, armored woodlice, scavenge slowly across the muddy sea floor. They move with a deliberate, unhurried pace, their hard shells protecting them in the cold, dark environment. These ancient creatures are the quiet cleaners of the deep, patiently waiting for food to fall from above, living a slow, peaceful life in the eternal night. Many creatures in the twilight zone use counter-illumination, producing light on their bellies that perfectly matches the faint sunlight filtering down from above. This clever camouflage makes them completely invisible to predators looking up from below, blending seamlessly into the glowing surface. It is a gentle, silent magic, a way of disappearing into the light, of becoming one with the faint glow of the ocean above. In the deep, cold waters, giant sea spiders with long, spindly legs drift gracefully through the current. Unlike their land-dwelling cousins, these deep-sea giants can be as large as dinner plates, their bodies adapted to the oxygen-rich, freezing water. They move with a slow, elegant grace, their long legs trailing behind them like silk threads in the dark, peaceful water. The oldest water in the ocean is found in the deep Pacific, water that has been isolated from the surface for over 1,000 years. It carries the chemical memory of a world long gone, a silent, ancient fluid that has traveled the globe in the slow, deep currents. To study this water is to look back in time, to touch a liquid that has been hidden in the dark since before the rise of human civilization. Underwater rivers flow across the ocean floor, channels of dense, salty water that carve paths through the sediment just like rivers on land. They have banks, meanders, and even waterfalls, creating a hidden, submerged landscape that mirrors the world above. These silent, flowing rivers carry nutrients and life through the deep, a secret network of water within the water, quietly shaping the sea floor. In the polar regions, the sound of melting ice creates a gentle, crackling symphony beneath the waves. As ancient glaciers calve and melt, they release trapped air bubbles that pop and fizz in the water, creating a soothing, rhythmic background noise. It is the sound of the earth breathing, a quiet, natural music that has echoed in the cold oceans for millennia, a peaceful lullaby of ice and water. Beneath the North Sea lies Doggerland, a vast, ancient landscape that was once home to early human hunters, now swallowed by the rising ocean. Hidden beneath the waves are the buried forests, river valleys, and settlements of a lost world, preserved in the cold, dark mud. It is a silent, submerged history, a reminder of the ocean's power to reclaim the land, keeping our ancient past safe in its deep, quiet embrace. The ocean acts as a massive biological carbon pump, where tiny marine plants absorb carbon from the air and carry it to the deep when they die. This slow, gentle rain of carbon sinks through the water, locking away the elements of the atmosphere in the dark, cold depths for centuries. It is a quiet, vital service, a silent, invisible process that helps keep the Earth's climate balanced and stable, a gentle breath of the planet. Vast underwater meadows of seagrass sway gently in the shallow currents, providing a nursery for countless young fish and invertebrates. These meadows are incredibly efficient at storing carbon, burying it in the sediment where it can remain for thousands of years. They are the quiet, green lungs of the coastal ocean, swaying peacefully in the tide, a soothing, rhythmic dance of life that supports the entire marine ecosystem. At the hydrothermal vents, black smokers spew dark, mineral-rich water into the freezing ocean, creating towering chimneys of sulfide. The stark contrast between the superheated, dark water and the freezing, clear ocean creates a beautiful, swirling, smoke-like effect. It is a dramatic, yet peaceful display of the Earth's inner heat, a quiet, powerful force shaping the deep sea in a constant, gentle flow. Sea cucumbers glide slowly across the ocean floor, their soft, leathery bodies gently pulsing as they move. They ingest the muddy sediment, extracting tiny bits of organic matter, and excrete clean sand, quietly tilling the sea floor. They are the gentle gardeners of the deep, moving with a slow, hypnotic rhythm, keeping the ocean floor clean and healthy in a quiet, endless cycle of renewal. Decades ago, hydrophones picked up a mysterious, ultra-low frequency sound known as the bloop, a noise so powerful it was detected across thousands of miles of ocean. Though eventually attributed to shifting ice, the sound captured the imagination, a reminder of the vast, unknown mysteries that still echo in the deep. It is a haunting, beautiful reminder that the ocean still holds secrets, deep, resonant whispers from the dark that we have yet to fully understand. The Dumbo octopus flaps its large, ear-like fins in a slow, graceful motion, gliding through the deep water like a gentle, floating ghost. It is one of the most endearing creatures of the deep, moving with a quiet, peaceful elegance that seems almost magical. In the crushing darkness, it drifts silently, a soft, pale shape moving through the void, a beautiful, calming presence in the midnight zone. The ocean's global circulation, the great conveyor belt of water, takes over 1,000 years to complete a single journey around the globe. A single drop of water at the surface may take a millennium to travel to the deep ocean and back again, a slow, epic voyage through the dark. It is a reminder of the ocean's immense patience, a slow, steady rhythm that connects every part of the sea in a grand, eternal cycle. Marine snow, the gentle, continuous fall of organic matter from the surface, is the primary source of energy for the deep ocean. It drifts down like a soft, silent blizzard, a constant, peaceful nourishment that sustains life in the lightless depths. It is the quiet connection between the sunlit world above and the dark world below, a gentle, unbroken thread of life that falls endlessly through the water. The towering chimneys of hydrothermal vents grow slowly over time, building intricate, mineral-rich structures that can reach hundreds of feet tall. They are the silent, slow-building cathedrals of the deep, shaped by the steady flow of superheated water. In the darkness, they stand as monuments to the Earth's inner heat, quiet, enduring structures that provide a home for life in the most extreme conditions. The abyssal plains, vast, flat stretches of the ocean floor, are covered in a fine, soft ooze made of the microscopic remains of ancient marine life. It is a quiet, undisturbed landscape, a smooth, endless plain of soft sediment that stretches for thousands of miles. In this deep, silent world, time moves differently, the gentle accumulation of dust creating a peaceful, unbroken blanket over the history of the ocean. Even in the deepest, most crushing trenches, life finds a way, with specialized organisms thriving in the extreme pressure and cold. These trench ecosystems are isolated, unique worlds, evolving in their own quiet, dark corners of the planet. They are a testament to the resilience of life, a peaceful, enduring presence in the most unforgiving environments, a quiet, beautiful mystery at the very bottom of the sea. As we let these final thoughts drift away, allow the vastness of the ocean to wrap around you like a warm, heavy blanket. The ocean is deep, the ocean is quiet, and the ocean is at peace. Let its gentle rhythm slow your heart, let its vast, dark waters carry your worries away, and let yourself sink into the deep, restful sleep that awaits you. The tides will turn, the currents will flow, and the ocean will keep its eternal, peaceful watch. Sleep well. Sleep deeply. In the silent depths where light has never touched, the tripod fish rests on the ocean floor using 3 elongated fins as stilts. It waits motionless in the current, a patient sentinel in the eternal darkness, conserving energy in a world where food is scarce and every movement must be purposeful. This remarkable creature can remain still for hours, even days, becoming part of the landscape itself, a living statue in the deep. Beneath the Antarctic ice shelf, a hidden ocean teems with life in complete darkness and freezing temperatures. Seals dive beneath the ice, navigating through narrow breathing holes, their whiskers sensing the subtle changes in water pressure and temperature. This alien world beneath the ice is a realm of blue silence, where light filters through the frozen ceiling above, creating an ethereal, glowing cathedral of ice and water. The vampire squid, despite its ominous name, is a gentle creature that feeds on marine snow and organic debris. When threatened, it turns itself inside out, wrapping its cape-like webbing around its body in a defensive posture that reveals spiny projections. It is a living fossil, unchanged for millions of years, drifting through the oxygen minimum zone where few other creatures can survive, a quiet relic of ancient oceans. In the deep sea, the barrel-eye fish has a transparent head filled with fluid, through which its tubular green eyes can rotate upward to spot prey silhouetted against the faint light above. This remarkable adaptation allows it to look through its own head, a biological marvel that seems almost impossible. It drifts in the twilight zone, its transparent dome catching the dim light, a ghostly presence in the deep. The ocean's mesopelagic zone, or twilight zone, contains more fish biomass than all other zones combined, yet these creatures remain largely unseen by human eyes. They live in a world of perpetual dusk, their lives governed by the faintest traces of sunlight that penetrate from above. This hidden world pulses with life, a vast, dark ecosystem that plays a crucial role in the ocean's health and the planet's carbon cycle. Giant larvaceans build intricate, mucus houses that filter seawater, creating bubbles of filtered water in the deep ocean. These transparent, gelatinous structures can be as large as a human, though the creature inside is only a few centimeters long. When the house becomes clogged, the larvation abandons it, and the structure sinks to the ocean floor, carrying carbon and nutrients to the deep in a continuous, gentle rain. In the deep ocean, the fang-tooth fish has the largest teeth relative to body size of any fish in the sea. Despite its fierce appearance, it is a small, harmless creature that drifts in the darkness, its oversized fangs curving back to prevent prey from escaping. It is a paradox of the deep, terrifying in appearance yet gentle in nature, a reminder that looks can be deceiving in the mysterious ocean depths. The ocean's Hadal zone, named after Hades, the Greek god of the underworld, encompasses the deepest trenches on Earth. Here, in complete darkness and under crushing pressure, life persists in forms we are only beginning to understand. It is the final frontier of our planet, a realm more inaccessible than the surface of Mars, holding secrets that may reshape our understanding of where life can exist. Deep-sea corals, unlike their shallow water relatives, do not rely on sunlight and can live in complete darkness. They grow incredibly slowly, some species adding only millimeters per century, creating ancient structures that have stood for thousands of years. These cold-water corals form reefs that provide habitat for countless deep-sea creatures, silent, slow-growing cathedrals in the dark. The pelican eel has a massive, expandable jaw that can open wide enough to swallow prey larger than itself. It drifts through the deep with its mouth agape, a passive hunter waiting for unsuspecting prey to wander into its trap. Its body is soft and gelatinous, adapted to the extreme pressure of the deep, a bizarre and beautiful creature that seems more alien than earthly. In the Southern Ocean, the Antarctic krill forms massive swarms that can be seen from space, creating reddish patches on the ocean surface. These tiny crustaceans are the foundation of the Antarctic food web, supporting whales, seals, penguins, and countless other creatures. They migrate vertically every day, rising to the surface at night to feed on plankton, then sinking to the depths during the day, a daily rhythm that has persisted for millions of years. The deep sea is home to the immortal jellyfish, a tiny creature that can revert back to its juvenile form when stressed or aging, theoretically allowing it to live forever. It drifts through the ocean, a small, transparent bell pulsing gently, carrying within it the secret of biological immortality. It is a humble creature with an extraordinary ability, a quiet marvel in the vast ocean. Oceanic ridges, where tectonic plates pull apart, create the longest mountain ranges on Earth, stretching for over 40,000 miles through every ocean. These underwater mountains are constantly being formed as magma rises from the Earth's interior, creating new ocean floor in a slow, continuous process. It is the planet's greatest geological feature, hidden beneath the waves, shaping the ocean and the continents above. The gulper eel can dislocate its jaw to swallow prey whole, its stomach expanding to accommodate meals much larger than its own body. In the food-scarce deep ocean, this adaptation allows it to take advantage of any opportunity, no matter how large. It is a creature of extremes, living in a world where survival requires remarkable adaptations, a testament to life's ingenuity in the face of challenge. Deep in the cold, dark waters of the Arctic, the Greenland shark glides with a slow, ancient grace. These magnificent creatures are the longest-living vertebrates on Earth, with some individuals estimated to be over 400 years old. They move through the freezing depths at a leisurely pace, their lives unfolding in slow motion, witnessing centuries of ocean history pass by in quiet, silent observation. They are the gentle elders of the sea, carrying the memory of a world long past within their slow-beating hearts. Beneath the waves, the Sofar Channel acts as a hidden acoustic highway, a layer of water where sound waves become trapped and can travel for thousands of miles without losing their energy. In this deep, quiet corridor, the low-frequency calls of whales can cross entire ocean basins, connecting distant populations in a web of sound. It is a secret, invisible network of communication, a deep ocean telephone line that has linked marine life across the globe for millions of years. In the inky blackness of the deep sea, the glass squid drifts with a body so completely transparent that it is nearly invisible. Its internal organs are the only hint of its presence, glowing faintly with bioluminescent counter-illumination to erase its silhouette against the faint light from above. It is a phantom of the twilight zone, a creature of pure water and light, moving through the abyss like a whispered secret, unseen and untouched. Along the mid-Atlantic ridge, the Lost City hydrothermal vent field rises from the ocean floor, not as dark, smoking chimneys, but as towering, white carbonate structures. These alkaline vents release warm, mineral-rich water that has interacted with the Earth's mantle, creating a gentle, glowing oasis in the cold deep. The intricate, castle-like spires of the Lost City are believed by some scientists to be the very environment where the first spark of life on Earth may have ignited, a quiet, warm cradle in the ancient ocean. When the full moon aligns with the summer solstice, certain coral reefs around the world participate in a synchronized, underwater snowstorm of life. Millions of coral polyps release their eggs and sperm into the water column at the exact same moment, creating a swirling, glowing cloud of pink and white that rises toward the surface. It is a breathtaking, silent celebration of renewal, a magical, fleeting dance of creation that ensures the survival of the reef for another generation. The ocean is home to the siphonophore, a creature that appears to be a single, massive animal but is actually a colony of thousands of tiny, specialized individuals working together in perfect harmony. Some of these colonies, like the Praia dubia, can stretch for over 150 feet, making them longer than a blue whale. They drift through the open ocean like a delicate, glowing ribbon, a fragile, collective organism moving as one in the vast, open water. In the crushing depths, deep-sea gigantism transforms familiar creatures into massive, gentle giants. The Japanese spider crab spans over 12 feet from claw to claw, its long, spindly legs moving with a slow, deliberate elegance across the seafloor. The giant isopod, a distant cousin of the pill bug, grows to the size of a small dog, scavenging patiently in the dark. In the deep, cold, oxygen-rich water, life takes on a larger, slower, more majestic form. The mantis shrimp possesses the most complex eyes in the animal kingdom, capable of seeing polarized light and colors that the human mind cannot even imagine. Though they are known for their powerful strikes, in the quiet depths, their vibrant, kaleidoscopic vision allows them to navigate a world of hidden signals and secret patterns. They perceive the ocean not just as water and rock, but as a canvas of invisible light, a rich, hidden spectrum of beauty that surrounds them. Far below the turbulent surface, the ocean's gyres rotate in massive, slow-moving circles, driven by the Earth's rotation and global wind patterns. These giant, swirling systems of currents take years to complete a single rotation, trapping floating debris and creating unique, isolated ecosystems in their centers. They are the great, slow-turning wheels of the sea, quietly redistributing heat, nutrients, and life across the planet in a rhythm too vast for us to perceive. The heart of a blue whale is the size of an automobile, beating with a slow, powerful rhythm that can be felt through the water for miles. When the whale dives, its heart rate slows dramatically, conserving oxygen and energy as it plunges into the cold, dark depths. This slow, steady drumbeat is the engine of the largest creature to ever live, a deep, resonant pulse that echoes the ancient, peaceful rhythms of the ocean itself. In the deep sea, the anglerfish female carries her glowing lure, a modified dorsal spine tipped with bioluminescent bacteria, swinging it gently in the darkness. It is a tiny, solitary star in a universe of black, a beacon of false hope for curious prey. Yet, in this harsh environment, it is also a symbol of profound adaptation, a quiet, patient strategy for survival in a world where energy is the most precious commodity of all. The ocean floor is scattered with manganese nodules, potato-sized rocks that grow incredibly slowly, accumulating layers of minerals over millions of years. They rest on the soft, undisturbed sediment of the abyssal plain, silent witnesses to the slow, continuous rain of marine snow. These ancient stones hold the chemical history of the ocean within their concentric rings, a quiet, geological record of time passing in the deep. When a sperm whale dives into the midnight zone, it enters a world of absolute silence and crushing pressure, relying entirely on its echolocation to navigate. It sends out powerful clicks that bounce off the hidden contours of the sea floor and the bodies of giant squid, painting a sonic picture of the darkness. It is a master of the deep, moving with a quiet, confident grace, guided by the echoes of its own voice in the endless night. The sea pen, a relative of the coral, stands anchored in the soft mud of the ocean floor, its feather-like colonies swaying gently in the current. When disturbed, many species of sea pen emit a soft, greenish-blue bioluminescent glow, rippling down their length like a wave of light. It is a delicate, living lantern in the deep, a fragile, beautiful response to the touch of the water, glowing softly before fading back into the dark. The giant oarfish, often the inspiration for ancient sea serpent legends, is the longest bony fish in the world, living deep in the ocean and rarely coming to the surface. Its long, silver, ribbon-like body shimmers in the dark water as it moves with a slow, undulating grace, a mysterious and elusive creature of the deep pelagic zone. Beneath the waves of the Denmark Strait lies the largest waterfall in the world, an entirely underwater cascade known as the Denmark Strait Cataract. Cold, dense water from the Nordic seas plunges over a massive drop into the deep Atlantic, a silent, invisible waterfall moving billions of tons of water every second, shaping the deep ocean currents. In the bioluminescent bays of places like Puerto Rico, microscopic organisms called dinoflagellates light up the water with a brilliant blue-green glow when disturbed. When a boat moves through the water at night, it leaves a trail of glowing stars in its wake, creating a magical, shimmering reflection on the dark surface. The remarkable regenerative abilities of sea stars allow them to regrow lost arms, and in some species, an entirely new body can grow from a single severed arm. This quiet, biological resilience is a testament to the enduring nature of marine life, a slow and steady process of healing and renewal in the tidal pools and reefs. The Great Blue Hole of Belize is a massive, perfectly circular underwater sinkhole that plunges deep into the earth, its dark, sapphire waters hiding ancient stalactites and stalagmites. These limestone formations are remnants of a time when this deep pit was a dry cave above the sea, a frozen moment of geological history preserved in the deep blue. The narwhal, often called the unicorn of the sea, navigates the icy Arctic waters using its long, spiraled tusk, which is actually a highly sensitive sensory organ. This remarkable tooth can detect changes in water temperature, salinity, and pressure, allowing the narwhal to taste the ocean and find its way through the freezing, dark waters. The giant oceanic manta ray glides through the open water with a wingspan of up to 23 feet, moving with the slow, graceful elegance of a bird soaring through the sky. These gentle giants filter plankton from the water as they swim, their massive pectoral fins flapping in a steady, hypnotic rhythm that carries them across the vast ocean. The towering kelp forests of the Pacific coast are dense, swaying underwater jungles where giant seaweed grows up to 2 feet a day, reaching for the sunlight. These lush, green canopies provide vital shelter and hunting grounds for countless fish, seals, and sea otters, creating a vibrant, bustling ecosystem in the cold coastal waters. Sea otters wrap themselves in strands of kelp while they sleep to prevent drifting away in the ocean currents, floating peacefully on their backs. This charming, quiet behavior keeps them anchored in place, allowing them to rest safely in the open water, a peaceful image of adaptation and survival in the wild ocean. In the deepest, most crushing trenches, giant amphipods resembling translucent shrimp scavenge on the organic matter that sinks from the surface. They thrive in the extreme pressure and freezing cold where no other large creatures can survive, a silent, resilient multitude living at the very bottom of the world. The oceanic white-tip shark is a slow, deliberate predator of the open ocean, known for its calm demeanor as it glides effortlessly through the vast, empty blue expanses far from land. It moves with a steady, unhurried rhythm, a quiet master of the pelagic realm, patrolling the deep blue waters with ancient, instinctual grace. The bristlemouth, a tiny, dark fish with a mouth full of needle-like teeth, is actually the most abundant vertebrate on the entire planet, outnumbering all other fish combined. These small creatures fill the twilight zone in silent, invisible multitudes, a vast, hidden population that plays a crucial role in the deep ocean food web. The vast majority of the rain that falls on land originates from the evaporation of ocean water, a continuous, gentle cycle where the sea breathes moisture into the sky. This invisible transfer of water connects the deep ocean to the highest mountains, a quiet, planetary rhythm that sustains all terrestrial life. The leatherback sea turtle, the largest of all living turtles, migrates across entire ocean basins, navigating thousands of miles of open water with remarkable precision. Its leathery shell and powerful flippers allow it to dive to great depths in search of jellyfish, a solitary, ancient traveler crossing the vast, blue expanse. The ancient sea lilies, or crinoids, cling to rocks in the deep ocean currents, their feathery arms swaying gently to catch drifting food particles. These living fossils have survived since the time of the dinosaurs, standing like delicate, swaying flowers in the cold, dark water, a quiet, enduring presence in the deep sea. The cookie-cutter shark, a small but formidable predator of the deep, leaves perfectly round, crater-like wounds on its much larger prey. It attaches itself to whales, dolphins, and even submarines, using its specialized lips to create a vacuum seal before taking a precise, circular bite. It is a quiet, efficient hunter in the open ocean, leaving behind strange, geometric scars on the giants of the sea. In the freezing waters of the Antarctic, ice fish swim with blood that is completely transparent, lacking the red hemoglobin found in most other vertebrates. This unique adaptation allows their blood to carry oxygen more efficiently in the cold, oxygen-rich water, making them appear ghostly and pale as they drift through the icy currents. They are silent, translucent ghosts of the Southern Ocean, adapted to a world of extreme cold. The ocean's thermocline acts as a barrier between the warm surface waters and the cold deep waters, a layer where temperature drops rapidly with depth. This invisible wall affects how sound travels, how nutrients mix, and where marine life can survive, creating distinct layers within the ocean that rarely blend. It is a subtle, powerful boundary in the sea, shaping the distribution of life and energy in the deep. Giant barrel sponges, some of the oldest living organisms on Earth, can live for over 2,000 years, growing slowly in the deep Caribbean reefs. Their massive, hollow structures provide shelter for countless small fish and crustaceans, acting as underwater apartment complexes in the dark depths. They stand as silent, ancient sentinels of the reef, filtering gallons of water every day in a slow, steady rhythm. The flying fish glides above the ocean surface for hundreds of feet, using its enlarged pectoral fins to escape predators below. For brief, magical moments, it becomes a creature of both air and water, skimming the waves in a graceful, silvery arc before diving back into the safety of the deep. It is a fleeting bridge between two worlds, a quick, elegant dance on the edge of the sea. Deep in the Gulf of Mexico, brine pools form on the seafloor, lakes of super salty water that are denser than the surrounding ocean. These toxic, shimmering pools have their own shorelines and waves, preserving any creature that falls into them in a state of perfect, eerie suspension. They are alien landscapes beneath the sea, hidden worlds within the ocean that defy the normal rules of marine life. The mantis shrimp strikes with the speed of a bullet, creating cavitation bubbles that collapse with the force of a small explosion. Though tiny, this punch generates heat and light, stunning or killing prey instantly. In the quiet coral reefs, this explosive power is contained within a colorful, intricate shell, a hidden violence in a beautiful package. Oceanic fronts, where different water masses meet, are often visible from space as sharp lines of color and temperature. These boundaries are rich in nutrients and life, attracting large numbers of fish, birds, and marine mammals that gather to feed in the productive waters. They are dynamic, shifting borders in the sea, constantly moving and changing, marking the meeting places of different ocean currents. The nautilus, a living fossil that has remained unchanged for millions of years, moves through the water by adjusting the gas in its chambered shell. Its spiral shell grows with it, adding new chambers as it ages, a perfect mathematical curve that records its life history. It drifts in the twilight zone, a gentle, ancient creature carrying its home on its back, a quiet survivor from a distant past. Bioluminescent bacteria live in symbiosis with many marine animals, providing light in exchange for nutrients and shelter. In the bobtail squid, these bacteria help camouflage the animal by matching the moonlight from above, erasing its shadow from predators below. It is a delicate, cooperative partnership in the dark, a shared secret of survival in the midnight zone. The vast Sargasso Sea, defined by rotating currents rather than land, is a unique ecosystem of floating golden seaweed. It serves as a critical nursery for young eels and turtles, providing shelter and food in the middle of the open Atlantic. It is a drifting, sunlit island in the blue desert, a rare haven of stability in the ever-moving ocean. Deep-sea anglerfish males are tiny compared to females, often fusing permanently with their partners to become nothing more than a source of sperm. This extreme adaptation ensures reproduction in the vast, empty darkness where finding a mate is nearly impossible. It is a profound, biological sacrifice for survival, a quiet union in the lonely depths of the sea. The ocean's abyssal plains are covered in a fine, soft sediment called ooze, made up of the microscopic skeletons of dead plankton. This blanket of dust accumulates incredibly slowly, recording millions of years of climate history in its layers. It is a quiet, undisturbed archive of the past, a smooth, silent floor that stretches across the deepest parts of the world. Hammerhead sharks use their wide, flat heads to pin stingrays against the sandy bottom, using their unique shape as a tool for hunting. Their eyes are located at the ends of the hammer, giving them enhanced binocular vision and a wider field of view. It is a specialized, evolutionary design for precision and power, a silent, effective strategy in the coastal shallows. The giant Pacific octopus has 3 hearts and blue blood, pumping copper-based hemocyanin through its veins instead of iron-based hemoglobin. 2 hearts pump blood to the gills, while the third pumps it to the rest of the body, stopping when the octopus swims to conserve energy. It is a complex, alien physiology adapted for efficiency in the cold, oxygen-rich waters of the North Pacific. The lanternfish, one of the most abundant fish in the ocean, carries rows of tiny light-producing organs along its body, creating a constellation of bioluminescent dots in the darkness. These small fish migrate vertically every night, rising from the depths in silent, synchronized multitudes to feed in the surface waters, then descending again before dawn. They are the living stars of the deep ocean, a vast, glowing population that connects the surface to the abyss. In the cold, nutrient-rich waters of the upwelling zones, massive blooms of phytoplankton turn the ocean surface into swirling patterns of green and turquoise visible from space. These microscopic plants form the foundation of the marine food web, absorbing carbon dioxide and producing oxygen in a quiet, continuous process that sustains life across the globe. They are the invisible gardens of the sea, blooming and fading with the seasons in a gentle, planetary rhythm. The deep-sea crab, with its armor-like shell and long, spindly legs, scuttles slowly across the muddy ocean floor in search of food. These ancient arthropods have survived for millions of years, adapting to the extreme pressure and cold of the deep with slow metabolisms and efficient movement. They are the quiet scavengers of the abyss, moving with deliberate patience through the eternal darkness. Ocean eddies, massive rotating bodies of water that break off from major currents, can be hundreds of miles wide and persist for months or even years. These swirling vortices transport heat, nutrients, and marine life across vast distances, creating isolated ecosystems that drift through the open ocean like mobile islands. They are the ocean's weather systems, powerful, slow-moving storms of water that shape the distribution of life in the sea. The sea dragon, a close relative of the seahorse, drifts through the kelp forests with leaf-like appendages that provide perfect camouflage among the swaying seaweed. These delicate, ornate creatures move with an almost magical grace, their elaborate fins fluttering gently as they hover in the current. They are living works of art, beautiful, peaceful inhabitants of the coastal waters that seem more like fantasy than reality. In the deepest trenches, the pressure is so immense that it would crush a human instantly, yet specialized organisms thrive in these conditions. Their bodies are filled with protective molecules that prevent their proteins from being crushed, allowing them to function normally in an environment that should be lethal. They are the ultimate survivors, living testaments to life's incredible ability to adapt to the most extreme conditions imaginable. The ocean's salinity varies from place to place, with the saltiest waters found in areas of high evaporation and the freshest near river mouths and melting ice. These differences in salt content create density gradients that drive ocean circulation, influencing climate and marine life distribution across the globe. It is a subtle, powerful force in the sea, a quiet driver of planetary-scale processes. The giant clam, the largest bivalve mollusk in the world, can grow to over 4 feet across and weigh more than 500 pounds. Its colorful, iridescent mantle houses symbiotic algae that provide food through photosynthesis, creating a mutualistic relationship that has persisted for millions of years. It is a gentle, stationary giant of the reef, filtering water and providing habitat in a slow, steady rhythm of life. Deep-sea shrimp possess specialized eyes that can detect the faintest traces of bioluminescence, allowing them to navigate and hunt in the near-total darkness of the deep ocean. Some species have eyes that look upward to spot the silhouettes of prey against the faint surface light, while others look downward to detect bioluminescent signals. They are the silent watchers of the deep, their vision adapted to a world where light is rare and precious. The ocean's mixed layer, the upper portion of the water column that is well mixed by wind and waves, varies in depth from a few meters to several hundred meters depending on location and season. This layer is where most marine life concentrates, where sunlight penetrates, and where the ocean interacts most directly with the atmosphere. It is the ocean skin, a dynamic, ever-changing boundary between the sea and the sky. The vampire squid, despite its fearsome name, is a gentle filter feeder that drifts through the oxygen minimum zone, capturing marine snow with its long, retractable filaments. When threatened, it can turn itself inside out, wrapping its webbed arms around its body to reveal spiny projections that deter predators. It is a living paradox, a creature of darkness that is both ancient and unique, a quiet survivor in one of the ocean's most challenging environments. Oceanic plateaus, vast underwater regions of elevated seafloor created by massive volcanic eruptions millions of years ago, rise from the abyssal plains like submerged continents. These features influence ocean currents, create unique habitats, and hold clues to Earth's geological past, including mass extinction events and climate shifts. They are the hidden continents of the sea, silent witnesses to planetary-scale changes over deep time. The sea cucumber, a soft-bodied echinoderm, moves slowly across the ocean floor, ingesting sediment and extracting organic matter with its feathery feeding tentacles. Some species can eject sticky, toxic threads to deter predators, while others can regenerate lost body parts with remarkable speed. They are the quiet gardeners of the deep, tilling the sediment and recycling nutrients in a slow, continuous cycle of renewal. In the polar oceans, the formation and melting of sea ice creates a seasonal rhythm that drives biological productivity, with massive blooms of algae growing on the underside of the ice in spring. This ice algae provides the first food of the year for zooplankton, setting the stage for the entire polar food web. It is a delicate, frozen ecosystem that pulses with life during the brief polar summer, then retreats into darkness during the long winter. The deep scattering layer, a dense band of marine organisms that reflects sonar signals, rises and falls with the daily cycle, creating a false bottom that confused early oceanographers. This layer is composed of countless small fish, squid, and crustaceans that migrate vertically to feed, creating the largest biomass migration on Earth. It is a living, breathing layer in the ocean, a daily pulse of life that connects the surface to the deep in a silent, synchronized dance. In the inky blackness of the deep ocean, the stoplight loosejaw fish possesses a rare and remarkable ability. It produces red bioluminescent light. Since most deep-sea creatures cannot see the color red, this tiny predator uses its hidden red spotlight to illuminate prey without alerting them, hunting in a secret spectrum of light that belongs only to the midnight zone. It is a silent, invisible hunter, moving through the abyss with a quiet, evolutionary perfection. Beneath the waves, the phenomenon of milky seas occasionally transforms vast stretches of the ocean into a glowing, ethereal landscape. Caused by massive colonies of bioluminescent bacteria, these areas emit a steady, ghostly white light that can be seen from space, turning the dark ocean into a luminous, dreamlike plane. It is a rare, magical event, a silent, glowing blanket of life that has inspired sailors' tales for centuries. The majestic humpback whale undertakes some of the longest migrations of any mammal, traveling thousands of miles between polar feeding grounds and tropical breeding waters. They navigate this vast, featureless expanse using the Earth's magnetic field, the position of the stars, and the subtle acoustic landmarks of the ocean floor. Their journey is a slow, powerful rhythm, an ancient, instinctual dance that connects the freezing poles to the warm equator in a continuous, peaceful cycle. On the deepest parts of the ocean floor, strange underwater rivers of liquid carbon dioxide pool in deep depressions. Because this liquid is denser than the surrounding seawater, it flows along the bottom like a heavy, invisible stream, creating bizarre, shimmering shorelines in the abyss. It is a hidden, alien landscape, a quiet, chemical anomaly resting in the eternal cold of the deep sea. The remarkable green sea turtle possesses an internal compass that allows it to return to the exact beach where it was born, decades after it first hatched. Guided by the unique magnetic signature of the coastline and the subtle cues of the ocean currents, it completes a lifelong circle, returning to the sand to lay its own eggs. It is a profound, quiet devotion to place, a gentle, unbroken thread connecting generations across the vast ocean. In the crushing depths, deep-sea glass sponges build intricate, lattice-like skeletons out of silica, the same material used in fiber optic cables. These fragile, beautiful structures can live for thousands of years, standing like delicate, crystalline trees in the cold, dark currents. They are the ancient architects of the abyss, filtering the water with a slow, steady grace, providing shelter for countless tiny creatures in their transparent branches. The mimic octopus is a master of disguise, capable of altering its color, texture, and shape to impersonate other, more dangerous marine animals. By flattening its body and changing its movement, it can become a flatfish, a lionfish, or a sea snake, slipping away from predators in a quiet, fluid performance. It is a creature of pure adaptability, a silent, shifting phantom in the coral reefs, surviving through intelligence and illusion. In the freezing waters of the Antarctic, the sound of massive icebergs grinding together creates a deep, resonant, and strangely soothing symphony beneath the waves. As ancient glaciers calve and drift, they release trapped air bubbles that pop and fizz, adding a gentle, crackling rhythm to the deep blue. It is the sound of the earth breathing, a quiet, natural music that has echoed in the cold oceans for millennia, a peaceful lullaby of ice and water. When a great whale passes away, its massive body sinks slowly to the ocean floor in a gentle, months-long descent, creating an event known as a whale fall. This sudden, rich oasis of life in the barren deep sea provides food and shelter for hundreds of species for decades. Specialized bone-eating worms and blind crabs slowly break down the remains, turning a single moment of loss into a thriving, temporary city of life in the eternal darkness. The Baltic Sea holds a unique, layered secret. Its deep waters are completely devoid of oxygen, creating a vast, anoxic zone where almost no life can survive. This stillness has perfectly preserved ancient shipwrecks and sunken artifacts for centuries, protecting them from the wood-boring worms that destroy vessels in other seas. It is a silent, underwater museum, a quiet, undisturbed archive of human history resting in the cold, dark depths. The deep-sea anglerfish's glowing lure is not produced by the fish itself, but by millions of symbiotic, bioluminescent bacteria that live inside a specialized organ. The fish provides a safe home and nutrients for the bacteria, and in return, the bacteria provide a steady, cold light to attract prey in the pitch-black water. It is a profound, microscopic partnership, a shared secret of survival in the lonely, lightless depths of the sea. Oceanic trenches are not just deep holes, they are dynamic, active environments where tectonic plates collide and the Earth's crust is slowly recycled back into the mantle. In these extreme, high-pressure zones, unique ecosystems thrive around cold seeps, where methane and other chemicals slowly ooze from the seafloor, supporting communities of life that do not rely on the sun. They are the planet's hidden edges, places of immense power and quiet, enduring life. The remarkable ability of the sea star to regenerate lost limbs is a testament to the quiet resilience of marine life. Some species can regrow an entire body from a single severed arm, a slow, steady process of healing and renewal that takes place in the hidden crevices of the reef. It is a biological marvel, a peaceful, unhurried reconstruction of self in the gentle, rhythmic tides of the coastal shallows. The ocean's mesopelagic zone, or twilight zone, is home to the bristlemouth, a tiny, dark fish that is actually the most abundant vertebrate on the entire planet. These small creatures fill the mid-water depths in silent, invisible multitudes, their sheer numbers playing a crucial, stabilizing role in the global marine food web. They are the hidden foundation of the ocean, a vast, quiet population that outnumbers all other fish combined, drifting in the perpetual dusk. As these deep, quiet mysteries continue to unfold, imagine yourself floating weightlessly in the calm, supportive waters of the ocean. There is no rush, no pressure, only the gentle, rhythmic pulse of the sea. The water holds you, the darkness is peaceful, and the rhythm of the waves matches the slow, steady beat of your own heart. You are drifting, you are safe, and you are perfectly at rest. In the quiet, sunlit layers of the open ocean, the immortal jellyfish drifts with a secret that defies the natural order of life. When faced with injury, starvation, or old age, this tiny, transparent creature can reverse its biological clock, transforming its adult body back into a youthful polyp. It is a gentle, continuous cycle of renewal, a quiet reset button in the vast blue, allowing it to potentially live forever in a slow, peaceful loop of rebirth. Beneath the crushing weight of the deep sea, the Dumbo octopus glides through the darkness with a grace that seems almost magical. Named for the ear-like fins that flap rhythmically on its head, this gentle creature moves like a floating ghost, propelling itself with slow, deliberate pulses. It is a serene presence in the midnight zone, drifting effortlessly through the cold water, untouched by the chaos of the world above. Near the superheated chimneys of hydrothermal vents, giant tube worms stand anchored to the rock, their brilliant red plumes swaying gently in the warm, mineral-rich currents. These remarkable creatures have no mouth, no stomach, and no digestive system. Instead, they rely entirely on a peaceful, microscopic partnership with bacteria living inside them, which convert the toxic chemicals of the vent into life-sustaining energy. It is a quiet, profound symbiosis thriving in the most extreme darkness. Far from any landmass, the Sargasso Sea exists as a unique, floating ecosystem defined not by shores, but by the gentle, swirling embrace of ocean currents. Here, vast mats of golden seaweed drift on the surface, creating a sunlit, tangled sanctuary in the middle of the deep blue. It is a quiet, drifting island that has served as a nursery for young sea turtles and eels for millions of years, a peaceful haven in the open ocean. In the lightless depths, comb jellies drift like living prisms, their bodies lined with thousands of tiny, hair-like cilia. As these cilia beat to propel the creature through the water, they scatter light into brilliant, shifting rainbows that ripple across the jelly's transparent form. It is a silent, prismatic dance in the dark, a beautiful, fleeting display of color in a world where light is otherwise forbidden. The Greenland shark moves through the freezing Arctic waters with a slow, ancient lethargy, its metabolism so sluggish that it grows at a rate of barely 1 centimeter per year. Some of these magnificent, gentle giants are estimated to be over 400 years old, meaning they were swimming in the deep before the Industrial Revolution began. They are the quiet elders of the sea, witnessing centuries of ocean history pass by in slow, silent observation. Every single night, a silent, invisible migration unfolds in the twilight zone, as billions of tiny fish and plankton rise from the depths to feed in the surface waters. As dawn approaches, they sink back down into the darkness, creating a daily, vertical breathing rhythm of the ocean. It is the largest movement of biomass on the planet, a synchronized, peaceful dance that has persisted since the dawn of marine life, connecting the sunlit surface to the eternal deep. In the mid-water depths, the giant larvation builds an intricate, transparent house out of mucus, a delicate bubble that filters seawater for food. When the filter becomes clogged, the tiny creature simply swims out and abandons its home, allowing the structure to sink slowly to the ocean floor. This gentle, continuous rain of discarded mucus houses carries vital carbon and nutrients to the deep, a quiet, selfless gift to the abyssal ecosystem. Navigating the icy, treacherous waters of the Arctic, the narwhal uses its famous spiral tusk not as a weapon, but as a highly sensitive sensory organ. This remarkable tooth contains millions of nerve endings, allowing the narwhal to taste the water, detecting subtle changes in temperature, salinity, and pressure. It is a quiet, elegant tool for survival, guiding the unicorn of the sea through the freezing, dark currents with profound, intuitive grace. Beneath the waves of the Denmark Strait lies the largest waterfall in the world, an entirely underwater cascade known as the Denmark Strait Cataract. Cold, dense water from the Nordic seas plunges over a massive, submerged drop into the deep Atlantic, moving billions of tons of water every second. It is a silent, invisible river falling into the abyss, a powerful, quiet force that helps drive the global circulation of the ocean. In the warm, toxic outflow of hydrothermal vents, the Yeti crab thrives by cultivating its own food. Its pale, hairy arms are covered in specialized filaments that it gently waves in the mineral-rich water, farming colonies of bacteria. It is a peaceful, microscopic gardener of the deep, tending to its invisible crops in the extreme heat, a quiet testament to life's ability to find harmony in the most hostile environments. At the very bottom of the Mariana Trench, the Mariana snailfish glides gracefully through the crushing, lightless void. Its body is translucent and gelatinous, perfectly adapted to withstand pressures that would instantly destroy any surface creature. It moves with a slow, effortless drift, a quiet, resilient survivor at the very edge of life's limits, thriving in a world that should be completely uninhabitable. In the freezing polar currents, sea butterflies drift like delicate, living snowflakes. These tiny, swimming snails use wing-like appendages to flutter through the water, their fragile, transparent shells catching the faint, filtered light. They are a vital, beautiful part of the ocean's food web, drifting peacefully through the icy depths in a gentle, hypnotic dance of survival. Far below the turbulent surface, massive internal waves roll silently through the ocean's layers. These invisible, underwater tsunamis can be hundreds of feet tall, moving slowly through the dark, mixing nutrients and shaping the deep ocean environment. Though entirely unseen from above, they are a constant, powerful force, quietly stirring the deep waters in a slow, rhythmic, planetary pulse. Where fresh river water meets the salty ocean, invisible boundaries called haloclines form, creating distinct layers of water with different densities that refuse to mix. These shimmering, blurred zones bend light and create a dreamlike, surreal landscape beneath the waves. It is a quiet meeting place of two worlds, a gentle, shifting border where fresh and salt water dance together in a peaceful, eternal suspension. Deep in the freezing waters of the Southern Ocean, the colossal squid drifts in the eternal darkness. Unlike its cousin the giant squid, it possesses short, thick tentacles lined with swiveling hooks, perfectly adapted for capturing large prey in the cold, lightless depths. It is a massive, quiet presence in the abyss, moving with a slow, deliberate grace, a true giant of the deep sea that rarely encounters the world above. In the quiet, sunlit layers of the open ocean, sperm whales engage in a remarkable and peaceful behavior known as vertical sleeping. They hang motionless in the water column, their massive bodies suspended like sleeping giants, drifting gently with the currents. It is a rare, serene moment for these powerful creatures, a quiet pause in their deep dives, resting in the calm, blue expanse of the sea. Far from the coast, in the vast, empty expanses of the pelagic zone, the oceanic white-tip shark glides with a slow, deliberate grace. Known for its calm demeanor, it moves with an unhurried rhythm, its long, white-tipped fins cutting smoothly through the water. It is a quiet wanderer of the open ocean, patrolling the deep blue with ancient, instinctual patience. In the polar regions, as seawater freezes into sea ice, it rejects the salt it contains, creating dense, cold brine that sinks rapidly to the ocean floor. This quiet, physical process, known as brine rejection, helps drive the global ocean circulation, pulling surface water down into the deep. It is a silent, planetary mechanism, a gentle, invisible force that shapes the climate of the entire world. At underwater cleaning stations, giant oceanic manta rays hover gracefully over coral reefs, allowing smaller fish to nibble away parasites. They remain perfectly still, their massive wings spread wide, trusting the tiny cleaners to tend to their skin. It is a peaceful, cooperative moment in the reef, a quiet interaction between giant and minnow in the vibrant, sunlit waters. Deep beneath the turbulent surface, a hidden layer of water known as the Sofar Channel acts as an acoustic highway. Sound waves become trapped in this zone, allowing the low-frequency calls of whales to travel for thousands of miles without losing their energy. It is a secret, invisible network of communication, a deep ocean telephone line that connects distant populations in a web of sound. Along the rocky coastlines of the Pacific, giant kelp forests sway in the rhythmic pull of the tides. These towering underwater plants can grow up to 2 feet a day, reaching for the sunlight and creating a dense, green canopy. They provide vital shelter and hunting grounds for countless fish, seals, and sea otters, a vibrant, bustling ecosystem in the cold coastal waters. In the kelp forests of the North Pacific, sea otters wrap themselves in strands of giant kelp before they sleep to prevent drifting away in the currents. Floating peacefully on their backs, they rest securely in the gentle sway of the water. It is a charming, quiet behavior, a peaceful image of adaptation and survival in the wild, open ocean. The ocean's global conveyor belt, driven by differences in temperature and salinity, moves vast amounts of water around the planet in a slow, continuous loop. This thermohaline circulation takes over 1,000 years to complete a single journey, quietly redistributing heat, nutrients, and life across the globe. It is the great, slow-turning wheel of the sea, a planetary rhythm too vast for us to perceive. At the very bottom of the Mariana Trench lies the Challenger Deep, the lowest known point in the Earth's crust. Here, the pressure is over 1,000 times greater than at the surface, a crushing weight that would instantly destroy any surface creature. Yet, in this extreme, lightless void, specialized organisms thrive, a quiet, resilient testament to life's ability to adapt to the most unforgiving environments. Along the mid-ocean ridges, hydrothermal vents known as black smokers spew superheated, mineral-rich water into the freezing ocean. The dark, smoke-like plumes rise and swirl, creating towering chimneys of sulfide that provide a warm, chemical oasis in the cold deep. It is a dramatic, yet peaceful display of the Earth's inner heat, a quiet, powerful force shaping the deep sea. Once a year, under the light of a full moon, entire coral reefs participate in a synchronized, underwater snowstorm of life. Millions of coral polyps release their eggs and sperm into the water column at the exact same moment, creating a swirling, glowing cloud of pink and white. It is a breathtaking, silent celebration of renewal, a magical, fleeting dance of creation that ensures the survival of the reef. Drifting down from the sunlit surface, marine snow consists of a continuous shower of organic debris, dead plankton, and fecal matter. This gentle, silent blizzard provides the primary food source for creatures in the deep ocean, carrying energy from the surface to the dark depths below. It is the quiet connection between the sunlit world and the abyss, a gentle, unbroken thread of life. In certain sheltered coastal bays, microscopic organisms called dinoflagellates create a magical, glowing phenomenon. When the water is disturbed by the gentle movement of a boat or the soft lapping of waves, they emit a brilliant blue-green light, turning the dark water into a shimmering, starry sky. It is a beautiful, fleeting display of bioluminescence, a quiet, natural magic that has inspired wonder for centuries. The abyssal plains are vast, flat stretches of the ocean floor, covered in a fine, soft sediment that has accumulated over millions of years. This quiet, undisturbed landscape stretches for thousands of miles, a smooth, silent floor that records the slow, continuous history of the deep. It is a peaceful, unbroken blanket over the past, a calm, eternal resting place in the heart of the ocean. The ocean is the great engine of the global water cycle, where warm surface water gently evaporates into the sky, forming clouds that travel across continents before falling as rain and returning to the sea. This endless, quiet loop has sustained the planet for billions of years, a gentle, breathing rhythm that connects the deepest trenches to the highest mountain peaks in a continuous, peaceful exchange. In the cold, dark depths, the ghost shark or chimera glides with an ancient, ethereal grace. With its large, dark eyes and wing-like pectoral fins, it moves like a silent phantom through the abyss, a living relic from a time before the dinosaurs, untouched by the passage of time, drifting quietly through the eternal night. The magnificent whale pump is a quiet, biological miracle where whales dive deep to feed and return to the surface to release nutrient-rich plumes. This gentle fertilization of the surface waters stimulates the growth of phytoplankton, creating a peaceful, invisible cycle where the largest creatures nurture the smallest, sustaining the entire ocean ecosystem with a slow, steady rhythm. Deep in the lightless zones, bamboo coral grows with agonizing slowness, adding mere millimeters to its branches each year. These delicate, tree-like structures sway gently in the deep currents, standing as ancient, silent sentinels of the abyss, providing fragile, crystalline shelter for tiny, unseen creatures in the eternal dark. Beneath the crashing waves, the ocean produces a constant, low-frequency hum known as microseisms. This deep, resonant vibration is created by the relentless, gentle pounding of swells against the coastlines and the friction of storms far out at sea, a soothing, planetary heartbeat that has echoed through the water since the dawn of time. In the freezing, icy waters of the Antarctic, the leopard seal moves with a quiet, solitary grace beneath the ice shelves. Though a powerful predator, its movements in the deep blue are smooth and unhurried, a silent shadow gliding through the frigid, sunlit waters, perfectly adapted to the harsh, beautiful polar environment. At the very bottom of the ocean, the cellular structure of deep-sea fish is uniquely adapted to withstand crushing pressures. Their proteins are stabilized by special molecules that prevent them from being crushed, allowing these gentle creatures to drift effortlessly in an environment that would instantly destroy anything from the surface world, a quiet triumph of adaptation. In the vibrant, sunlit shallows, the clownfish and the sea anemone share a peaceful, symbiotic bond. The anemone's stinging tentacles provide a safe, protected home for the tiny fish, while the clownfish gently cleans its host and wards off predators, a quiet, harmonious partnership that has thrived in the coral reefs for millennia. The vampire squid, a gentle creature of the deep, casts a delicate, sticky web of mucus into the dark water to catch falling marine snow. It slowly reels in this invisible net, gathering the tiny, nutrient-rich particles that drift down from above, a quiet, patient method of survival in the food-scarce abyss, moving with deliberate, unhurried grace. The ocean possesses a remarkable ability to absorb and muffle sound, creating vast, quiet zones in the deep where noise from the surface cannot penetrate. In these silent sanctuaries, the only sounds are the gentle clicks of distant whales and the soft, rhythmic pulse of the deep currents, a profound, undisturbed peace that wraps the deep sea in silence. The oldest water in the world circulates slowly through the deep Pacific Ocean, having been isolated from the surface for over 1,000 years. This ancient, cold fluid carries the chemical memory of a world long past, moving with a sluggish, majestic grace in a slow, eternal loop that quietly connects the globe. When threatened in the dark depths, the Atala jellyfish, also known as the burglar alarm jelly, erupts in a dazzling, rotating display of bright blue bioluminescence. This sudden, brilliant flash is designed to attract larger predators to attack whatever is bothering it, a desperate, beautiful flare of light in the endless night, a fleeting star in the deep. The Antarctic Circumpolar Current is the most powerful ocean current on Earth, flowing endlessly around the southern continent without any landmass to block its path. This massive, unbroken river of cold water moves with a steady, unstoppable force, quietly connecting the Atlantic, Pacific, and Indian Oceans in a grand, planetary embrace. Sea turtles navigate the vast, featureless expanse of the open ocean by sensing the Earth's magnetic field. This internal, biological compass allows them to find their way across thousands of miles of water, guiding them back to the exact stretch of beach where they were born, a quiet, instinctual journey of profound precision and ancient memory. In the quiet moments of low tide, tidal pools become miniature, isolated worlds. As the water recedes, the gentle lapping of the remaining waves creates a soothing, rhythmic sound, while the creatures within wait patiently for the ocean's return, a peaceful, temporary stillness at the edge of the vast, breathing sea. The ocean's midnight zone is home to the black swallower, a fish that can consume prey up to 10 times its own mass, its stomach expanding to accommodate the massive meal in the food-scarce deep, a quiet testament to survival in the dark. In the shallow, sunlit waters, the parrotfish secretes a mucus cocoon around itself at night, a cozy, protective sleeping bag that masks its scent from nocturnal predators, allowing it to rest peacefully on the reef. The deep sea is home to the yeti crab, which farms bacteria on its hairy claws, waving them gently in the warm, mineral-rich currents of hydrothermal vents in a quiet, microscopic act of cultivation. Oceanic ridges are the longest mountain ranges on Earth, stretching over 40,000 miles beneath the waves, constantly creating new seafloor in a slow, silent, geological rhythm that shapes our planet. The gulper eel possesses a massive, expandable jaw and a bioluminescent tail lure, drifting passively in the dark, waiting for unsuspecting prey to wander into its trap in the lightless void. In the polar regions, the Weddell seal uses its teeth to maintain breathing holes in the thick sea ice, a quiet, daily ritual of survival in the freezing, isolated, and beautifully silent Antarctic waters. The ocean's abyssal plains are covered in a fine, soft ooze made of the microscopic remains of ancient marine life, a quiet, undisturbed blanket that records millions of years of planetary history in its layers. Sea pens, relatives of coral, stand anchored in the soft mud of the ocean floor, their feather-like colonies swaying gently and glowing with soft bioluminescence when disturbed by the passing current. The leatherback sea turtle migrates across entire ocean basins, navigating thousands of miles of open water with remarkable precision, a solitary, ancient traveler of the deep blue, guided by the Earth's magnetic field. In the deep, cold waters, giant sea spiders with long, spindly legs drift gracefully through the current, moving with a slow, elegant grace that seems almost magical in the crushing darkness. The ocean acts as a massive biological carbon pump, where tiny marine plants absorb carbon and carry it to the deep when they die, a quiet, vital service that helps regulate the Earth's climate in a slow, steady cycle. Beneath the North Sea lies Doggerland, a vast, ancient landscape now swallowed by the rising ocean, preserving the buried forests and settlements of a lost world in the cold, dark, protective mud. The giant beryl sponge can live for over 2,000 years, growing slowly in the deep reefs, its massive structure providing shelter for countless small fish in a slow, steady, unhurried rhythm of life. The narwhal navigates the icy Arctic waters using its long, spiral tusk as a highly sensitive sensory organ, tasting the water to detect subtle changes in temperature and salinity, a quiet, elegant tool for survival. As we reach the end of our ocean journey, we return to the quiet of the night, listening to the gentle, rhythmic lapping of the waves. The ocean is not just a vast body of water, it is the ancient, beating heart of our planet. Every drop of water that touches the shore has traveled across the globe, carrying the memory of distant storms, deep trenches, and quiet, sunlit reefs. You are made of the exact same water that fills these seas. The rhythm of your breath is the rhythm of the tides. You are not separate from this vast, peaceful expanse, you are a part of its eternal, calming flow. Let the weight of the day dissolve, sinking down, down, down into the soft, supportive depths of your bed. The ocean will keep its watch. The tides will keep their time. The deep, quiet mysteries will continue to unfold in the darkness, undisturbed and serene. You are safe. You are held. You are perfectly at rest. Drift now, into the deep, peaceful sleep that awaits you, carried by the gentle waves of dreams. Sleep well, dear traveler of the deep. Good night, and sweet dreams.